I've only been doing astrophotography for, it's going to be 3 years, in like another couple of weeks. And in the life of an astrophotographer, that's kind of short. We have members of this club that have done 10 plus years, and they know more than I'll ever learn, probably. So I was a little surprised to be asked, but I'm happy to do it. When I thought about what I would present here today, I could do a how-to, but I'm not sure what people really want to learn there. When you talk about astrophotography, what are you doing? Are you talking deep sky, comet? Are you talking planetary? Are you talking lunar? Very different domains, right?
Congratulations.
So I decided I was going to turn this into more of a personal story, because it's the only thing I can really speak to, right? I started astrophotography a while back, and I did a bunch of things, and I can share that with you. It's not right or wrong, it's just what I did. And so that's what this will be. It'll be more of a personal talk, if you will. So, astrophotography. I took my very first astro image, August 5th in 2019. I took my last one, July 3rd, not too long ago. I'll probably take my next one starting tomorrow. But between those two dates has really been my journey so far. I started knowing nothing, I mean literally nothing, and I am where I am now. And I don't know where I'm going to be in a few years. But that's what I can really talk about. I've learned a lot in that period of time, but I also know there's a lot more to learn. So I'm going to share some aspects of my journey. I'm going to give you one caveat. I'm not really an expert. I'm a novice at this. I can't tell you the right way to do it, and I can't tell you the best way to do it. I can just tell you what I do and what works for me. Your mileage may vary. So a little bit of background on me. When it comes to astronomy, I've had a lifelong interest, even as a kid. Back in the 80s and 90s, before we really started the family, before crude took off, I was very active doing visual observing. And I was very active in AS-RAS. That was a big part of what I was doing. There's a lot of members of the club that liked to do the kind of observing I did. I spent a lot of time doing it. We didn't have an observatory back then. Then something happened. I moved down to Mendon because I wanted to get the darker skies. About the same time, I got a promotion at work. We built a house. We started a family, and I went back to grad school. And suddenly, there wasn't enough time in the universe to do astronomy. And I sort of fell away from that. And I've fallen away from it for 30 years. I hadn't come to a meeting in 30 years. Right? But I always knew I was going to be coming back. That was something I know I wanted to do. But I knew it probably had to happen when I had time. And in my mind, retirement was time. So a little bit more background. I've been working in the consumer imaging and computer science area for most of my career. 32 years at Kodak. I was involved in research labs and R&D, mostly working on consumer imaging, image understanding, image processing, those kinds of problem sets. After I left Kodak, I did some consulting and I worked with some small companies and startups, which I really enjoyed doing. And I was asked to be a CTO for a couple of those. And so that's what I did for my years after I left Kodak. But all that came to an end in 2019. The last company I was involved with was sold. I didn't like the people that it was being sold to, and I decided it was a great time to retire. And I knew then I suddenly had time. I had time and I knew what I wanted to do. I wanted to get back involved in astrophotography. Why astrophotography, right? Well, for me, it's kind of a unique blend of a lot of the interests that I have. I love science, I love technology, I love imaging, I love computers, gear, complex systems, problem solving, imaging just in general. I've always been a big fan of imaging. And frankly, I've always had this sense of wonder for the night sky. What a great way to get to know about it. But what is it about astrophotography that I find compelling? It's hard. It's really hard to do. It's precise and it's pretty unforgiving. And I think that gives you a unique challenge. And I kind of like challenges like that. It allows a person to capture amazing pictures of objects in the universe that you can't see with your eye. I did a lot of visual observing in my day, and everything with big light buckets, dots, something you can collect as much light as possible to try to get that sensation in there. You're making sure your eyes are dark adapted, all that. But then you can go and integrate light longer than your eye can in photography, and suddenly you're seeing things you can't see visually. And I find that pretty cool. I think it's kind of like magic. You capture some photons that travel 100 million light years to get to you, and you suddenly see those coming on your camera. I think that's pretty special. But ultimately, I think it's kind of a dash of the extraordinary in kind of the common elements in your life. How often do you get to look at things that just boggle your mind? And I think astrophotography is a great way to go at that. So my primary interest is many facets of astrophotography and astronomy. It's deep sky. And I really particularly appreciate something about the immense scale of the universe. Every time I look at a galaxy, know how far away those photons travel to get to my camera. That just rings my bell. That is pretty cool. And I think I'll probably always do that. As an example, here's a picture that I took recently. And specifically, I went to the James Webb website and I took it like but it's the kind of thing that really gets my juices flowing. So one of the things I realized when I started it and having no knowledge and trying to learn it, there's like this progression that astrophotographers go through. If you're going to do this stuff, you got to get gear. You have to have the right gear to hit critical mass so you can do what you want. I warn you, this is a phase that once you start, you will never finish. There's always something new and shiny that you have to get. You have to figure out how this gear comes together and you get some kind of image out. And I don't care how crummy that first image is, it's a huge accomplishment. You know how many hurdles you have to jump through? You have to put your gear together. You have to bring your camera to focus. You got to get the USB working. There's just so many things to trip you up. If you get any image, I don't care how bad it is, pat yourself in the back because it's a huge accomplishment. Once you're getting an image, no matter how bad, you can go on to the next phase, and that is maximizing the quality of the data you're collecting. This is about refining your technique, right? How do you set up your gear? How do you get your polar alignment? How do you do everything so the data you're getting is the best data you can get? That's a learning curve, and that's something that people can learn on, and you sort of plateau after a while because you get pretty darn good. It's good enough, and then there's other things you can learn. Then you got to develop your image processing skills. You got some data, great. What's it look like? Looks like nothing. You got to turn it into something that the human eye can appreciate. And that is another area where I guarantee you you will never be done learning how to do that. There's new techniques, there's new ways there's so many ways to skin a cat, you're going to try them all. And this last thing is kind of interesting. Developing your inner eye. People who get involved in astrophotography, they get used to working with the images. They know how to handle the problems. They know what they think it should look like. They think it should look like. Take the same data, give it to 10 astrophotographers, and you're going to get 10 different images that can be all excellent. But they look very different because everyone's signature style starts to come through. And you know how you develop that? I don't. But it seems to happen with everybody who does this kind of thing. And the more you do it, the more you have a signature style that is unique to you. And that's kind of cool, because that's an artistic aspect. So what are the key enablers to become an astrophotographer in deep sky specifically? You got to have interest and drive. If you have no interest, you're not going to do it. If you don't have drive, you're never going to be successful. So you need those two things. You need a few dollars. You're going to buy some toys, and you're going to need some dollars to do that. You got to have access to the sky. That's kind of handy. I don't always have good access to the sky, and that's something we're trying to fix right now. Got to have a supportive spouse because you're going to do crazy things at crazy times, and they better be patient, right, Jan?
Yeah.
That's right. But for me, the big thing, you got to have time. And for me, just give you an idea of what's typical for me. If I'm planning on the next shoot for one scope, I might spend more than 2 hours picking out what the object is, how I'm going to frame it, what my strategy is, which telescope is going to be used. It takes a lot of time to plan that out. I got to set up my gear every night. That takes me an hour and a half and take it down again for me. So there's a lot of time every night when you're doing that. When I'm capturing, If the weather gods permit, which rarely happens, I shoot for at least 3 to 5 nights on a project. And they're there all that night, capturing your data. Processing can take me 1 to 3 days to get what I want. It's not unusual for me to completely process an image, look at it and say, I hate it, and start over from scratch. Right? Or worse, I get done with it at 2 in the morning and I say, this is great. I wake up in the morning and look at it and say, oh my God, what was I thinking? This is terrible. And then for me, I actually do a web write-up for it where I document everything that happened with that project, including step-by-step processing of the image. That can take me 2 or 3 days. This is doing it. I'm not talking about learning it, and I'm not talking about improving it. Right? This is a big time commitment. And for me, retirement is what enabled it. That's retirement. I knew I would have the time to do this, and I decided I was going to go for it. So I want to share with you my observatory. Okay, on the left picture here, what you're looking at is my view down the driveway, due south, and you see my slice of sky between 2 tree lines. It's about that wide at the top. At the bottom, it's much narrower. I can get objects in there. I have, but just my window is very, very short. Now I turn around and look north. I have a hole in the trees where Polaris is. That is not a random hole. I have guys in ropes dangling from the trees, cutting branches so I can see Polaris. Because I set up in my driveway, multiple scopes, I got to do polar alignment. And I'm going to look at Polaris, darn it. And just transparency here, this is not an actual picture of Polaris. It's an incredible simulation. Just having any confusion there. But that's what I have to live with right now. And everybody has their own unique circumstances. And sometimes they're better, sometimes they're worse. There's always something you're dealing with. This is just one of the things I deal with. So how do you deal with that? I got to know when an object's going to clear one tree line, and I got to know when I'm going to lose it in the other tree line. So I took Stellarium, and I mapped out my tree line, and I put it in as a landscape view, and now I can predict that. I can figure out where that's going. And for me, from one side to the other, on any target, I get about 3 hours, and then I'm done. If we're in September or October, we got these long nights, I can probably shoot 3 or 4 targets that night. I have to, because the one I was shooting is gone behind the trees. I got to pick up another one. And I run 3 scopes right now, so I'm doing that 3 times. So that gets a little bit crazy, but that's what I deal with. I have a slice of sky that I can go through. So at some point, I knew I was going to get into this. I retired. Within 30 days, I had selected what gear I was going to get. So I want to talk about what my first rig was. That's a picture of it, but I started by doing internet research. When I was doing a lot of visual work, like I said, it was light buckets, and you were using DOMs. Well, now I'm looking at astrophotography, and I'm seeing smaller refractors being used with nice computerized go-to mounts, very different equipment. But I had an idea of what I wanted to do. I wanted maybe a 5-inch refractor, and I read really good things about Williams optics, so I was kind of interested in that. I had heard about Ioptron CM60 mounts that sounded pretty good. I sort of started to get a picture of what I was looking for. Some things I didn't have a clue. I didn't know what to do for a camera. I didn't know how to pick a camera that would be appropriate for that scope. So I had this rough idea. I did the next step. I placed a call to a really friendly guy at High Point Scientific. They have the technical advisor that'll talk you through. And he told me I had a really good feel for the scope. He picked out a camera, a one-shot color camera, which was a good fit for that. And he talked about how hard it was during COVID and the supply issues, how that, getting hold of some of these things is really tough. But just so happened, they had a Williams optic telescope that was in stock, just come in. They hadn't even registered it yet. And if I wanted, I could probably grab that. And Ioptron had a shipment coming where they had one more CM60 than they had orders for. And I could claim that if I wanted. This thing sounded pretty good. So I placed an instant $5,000 order. This was very simple to do. Then I had explained to my very surprised wife what I just did. This was not very easy to do.
It was.
So suddenly I was getting ready to sell a bunch of extra camera lenses because I created this $5,000 hole and I had to fill in some of it to smooth over the water. Remember this point. because this is a key point, and we'll talk about this again. So what I ended up getting was a Williams Optics 132 millimeter f7 FLT APO. Love the scope. It's a beautiful scope. I did get a 50 millimeter guide scope that was a Williams Optics as well. I got the CM60 mount, not one that's encoded or anything, just a simple mount. And then I got the 294M C Pro one-shot camera. One-shot camera is great if you're starting. It just simplifies everything. I looked into what it took to shoot with a mono camera, different filters and different calibration files and processing all the different. I said, anyone who did that has got to be insane. I want nothing to do with that. One-shot color, perfect. That's what I went with. And then I got a little 290mm Mini to act as the guide. For software, I was going to use APT, a photographic tool. I saw a backyard astronomer use it. Good enough for me, it's free. I can do that. Then for guiding, I was going to use PhD2. It's free and really, really good. Like that too. After $5,000, free was really nice. And for processing, Deep Sky Stacker, free. And Photoshop, which I've been using for like 20 years. I'm very comfortable with it, so that's cool. So now I got all this gear. I got to figure out what to do with it, right? So in the daytime, I got it all put together, figured out what you got to do to have the right spacing so the camera actually comes into focus. That was fun. I didn't have the extender, so I put a diagonal on it. So I had a very unusual first camera configuration, but I was able to get it sort of focused on the tree line, far, far away. So that worked out. That night, I got ready for my first try. So I did, for the first time in my life, a polar alignment by using the borescope. How evil is that? I'm kneeling in the driveway with my bad knees, looking up at an awkward angle, looking at a phone telling me where I should be putting Polaris, adjusting things. And there's something diabolical about making humans do that. But I did it. I don't know how well I did it, but I did it. I did a two-star calibration, so the go-to mount would point to something. And I told it to point to M8, first time through. And in the photographic tool, I didn't get any picture. I thought something was broken. I didn't realize it actually started a 60-second exposure. It takes 60 seconds. But suddenly, there's this image on my screen. Holy crap, that's more detail on M8 than I've ever seen visually. I got so excited, I took a picture of that screen. This is actually that screen at that moment. And I sent it to my kids. I said, oh, look what I did, look what I did. You know, I'm pretty darn proud of myself. Having that, I'm ready for my first image. That is my first image. So, 14 60-second subs. Poor focus because I never did anything past the tree line, and God knows how much colder it was. No guiding. I didn't know how to guide. I didn't know even how to start doing that. No calibration frames. Are you kidding me? I could barely get light frames in. And even then, I started slow with bias frames and then worked my way up to flats and things like that. Color. Where's my color? I got a one-shot color camera. Every image is a color. Where is my color? Well, it turns out that in Deep Sky Stacker, you got to tell it what Bayer pattern so it can debayer it, turn it into a color. Didn't know how to do that yet. So black and white it is. I can live with that. You know what? Absolutely, completely hooked. I was so excited by that. This is the first time I've seen anything like that. You know, 30 years ago when I was doing visual, I never saw that. This is stuff you saw in books coming out from, you know, the Palomar Observatory, right? And I did it in my driveway, and I didn't barely know what the heck I was doing, and I got it. I was so happy. So one thing I did realize, I have this thing called Astrophotography aerobics, I set up. I can't move it when it's together. So everything breaks down, and it's like a jigsaw puzzle. Bring out the legs, bring out the weight, or the mount, put the counterweight on, put the tube on. It's a lot of work, right? But I did it. It was awkward at first, and I literally spent more than 2.5 hours setting it up. But with time, I got a little bit more practice, and things worked a little bit better. I started getting early images. Now these images are some of my first. First off, they're guided. I focused them with that off screen. Woohoo, I'm getting fancy now. I think I did bias calibrations on these. So I'm working my way up the technology ladder. Woohoo, I'm doing great stuff. Of course, I look at it now, and I kind of notice that, geez, all the blacks are clipped. Stars have no color because they're saturated. Blew those out. And the color balance is very different from every frame. There doesn't seem to be a common color balance. It's wherever Photoshop left it. So I still had some work I was going to have to do on things. Kept working at it, and suddenly I come up with this image. And I was pretty happy. I took this picture. It was September 6th. It was 1.3 hours, my longest exposure to date. And I was pretty proud of this. I thought this had impact. I processed it with Photoshop. And I remember I showed my kids, and my oldest son, his comment was, "Wow, you did this?" Kind of insulting, I thought, but yes, I did. I did this. So I was starting to get some good results, and I was getting every time you get a result, you get excited. And when it's a better result than you got before, you're more excited. Here's another one I tried, M33. Notice the composition and how bad it really is. Composition was an alien concept at the time. I took the center of the object, I did a go-to to it, I got the exposure started, and things fell where things fell. It wasn't good. But for me, I mean, oh my God, I see a spiral structure. This thing is 2.7 million light years away. I can see little knots of color. I can see different structures in it. And then I came up with this image, and this image was kind of an interesting one. First off, I liked it. Second off, I started getting fancy. So this one, I created a set of subs. I got 30 at 180 seconds, and then I took a whole bunch with it was only 2 seconds. Trapezium gets blown out. I'm going to have two pictures, one with the trapezium not blown out, and the rest, and I'm going to put them together. I thought that was pretty fancy stuff. But this is the one I felt good enough about. It was the first image I ever shared with the broader AS-RAS community. And when I sent that out, Dan Kuchka and Gary Opitz reached out. And that was great. Because here's two guys who've been doing it for a long time. And they were willing to answer questions, critique what I did. I could ask them stupid questions that I couldn't figure out. To this day, we still have emails almost daily. It's been a great relationship, and I've learned so much from these guys. So that was really, really important to me. So I started to get some images that I was happy with. So some early learnings in those first few months of doing this. Tell your wife before you place your big equipment order. Trust me, it's a better strategy.
Replace girlfriend with that sentence.
What big equipment am I
132 millimeter mount, or size telescope. Beautiful telescope. Heavy telescope. If I'd done it differently now, I probably would have gotten like an 80 millimeter refractor. It would have been lighter, it would have been cheaper. I could put it on a lighter mount, and it would have been easier to track and easier to learn. But I have to learn the hard way, apparently.
Yeah, Pat, that's called a telescope.
Yeah.
It's the next book.
Yeah.
Now, these guys really aren't dark here.
Really. So I learned that PA with a borescope is medieval torture, and it's to be avoided. And I quickly found ways to avoid that. Plate solving, when I finally got that working, oh my God, that's magic stuff. You think you're pointed one place, and it tells you that you're not, but tells you where you are now, so you can. Nothing beats that stuff. And at first, every image you take, no matter how bad it is wonderful to you. You're oblivious to that because you've never had those results before, and it really enthuses you. So I have a telescope. I'm learning. Second telescope? Why would I ever have a second telescope? That's crazy stuff. But you know, you never know what's going to happen to you in life. So I told you I had to sell some lenses on eBay, right? So I did that. I had a surprise interaction with a guy who bought one of my lenses. He sent me a note back saying, "Hey, I got it. It's beautiful. Thanks much." And I said, "Hey, great. Thanks for buying it. I got to tell you, I got a big telescope. I got to pay for it, and you're helping do that." Telescope. Are you doing astrophotography? Well, I'm trying to learn. I tried to do that about 2002. Oh, man, I spent 3 years. I ordered a scope from Astro-Physics, and it took 3 years to come in. Then while I was waiting, I went out and bought mounts and CCD cameras. I had everything there. Got there, I never took a picture. I couldn't get it to work. I got frustrated with it. Been sitting in my dining room ever since. I go, you're kidding. I said, well, I've gotten past some of the problems. I can help you if you'd like. I'd be happy to help you try it again. You got some really nice gear there. Let me help. He goes, nah. He says, I think that's gone. My wife tells me that I can't buy any more toys until I get this out of my dining room. You wouldn't have an interest, would you? I say, well, I just bought a scope I'm trying to pay for. I really don't. So well, let me send you a list of what I got. So he sent me a list of what he had. It was amazing stuff. He had an Astro-Physics 130 that was in almost new shape. He had a Teleview 76. He had a Lost Mandy G11 mount. He had gobs of eyepieces and stuff. I went back and I said, listen, I really can't afford anything, but I'll give you an offer for the 2 scopes. It's a lowball offer. Please don't be insulted. Just tell me no. But, that's all I can really afford right now. And he came back and he says, well, I'll tell you what, throw another 1,000, I'll give everything. What do you mean everything? He goes, every piece of astronomical gear I have, down to the red flashlights. So I talked to my wife about it, and she agreed it was such a great deal that how could you not do that? So he was in Missouri. We drove and met. Was it Ohio? Indiana. We met at a hotel in Indiana. We met. Delightful gentleman. His wife was great. We spent the day together. We had dinner together. We've stayed in contact ever since. A great guy. I brought home a haul that would allow me to start having another telescope. So, anyways, I've already told all this. That's the pictures he was sending me. It was in really nice shape. So suddenly, surprise, I have this. It's not really ready to use. The mount was really old, hadn't been updated. I have no camera for it, right? And I didn't have money for a camera. So it took me over a year of fooling around with it. I ended up with something that looks like this. I replaced the Lost Mandy mount because it had a slip clutch, and every time I bumped it, it messed up my calibration, whereas the CM60 has a magnetic mount that's much more positive. But I also decided I'm going to try mono. Mono cameras are a lot of work, but they're a learning opportunity, and I kind of like this idea of narrowband imaging. I could experiment with it, so I decided to go that way. It took me about a year, maybe, but I finally got things going. If you're not familiar with mono cameras, the camera looks very similar to a one-shot color, but you have this filter wheel in front. And inside the filter wheel, you have usually 7 filters, LRGB if you want to be broadband, and the narrowband filters that are typically used. And so after a while, I got the camera and the filters, and I was ready to start. So pros and cons. A lot of flexibility in your imaging with a mono camera. A lot of efficiencies you can get. A lot of processing options. There's many ways to skin a cat. You're better able to deal with gradients from light pollution and moonlight, especially if you're doing narrowband. You're dealing with things in channels. You're dealing with filters that have eliminated extraneous light. There's some really positive things there. But it's more expensive, larger form factor, more complicated to use, more complicated optical paths. You have extra filters right in front of a sensor that could cause reflections. And processing takes a lot more time. So this was my very first image that I did. So, as I was saying, this is my first one. This was taken in July of 2020. This is really only 1.3 hours. It's not a lot of exposure yet. And it was the first time I processed things. I was pretty happy with what I was seeing there. Then I tried this guy. The elephant trunk. I did an LRGB. Kind of lacking in color. I think that's low exposure and lousy processing guy doing it. It just do too well. But I thought it looked kind of smoky and kind of mysterious. But it also sort of showed what you could do. So I went back a couple of nights later, and I picked up another hour of hydrogen alpha data and blended that in. And suddenly, wow, that's a really interesting image. That's the kind of thing I like to play with. And here's another one that's kind of interesting. This is the Crescent Nebula. Crescent Nebula doesn't have a lot of sodium data, so you often are only going to shoot the hydrogen alpha and the oxygen. So you have a bicolor image that you map on at RGB, and you get a color image like that. Again, it's some of the flexibility that you play with. So my early model learns is what I expected. It's time consuming, a lot more files to deal with at storage, longer and harder processing, but I really love the flexibility. I love the level of control that you can have with it, and I really loved narrowband. So that thing that I thought only an insane person would do, well, I decided that's pretty much all I was going to do. So I eventually moved over to model for everything. I never thought I would be doing that. So after using the gear I had for a while, I started realizing there were some pinch points, and I wanted to make some changes. So I started upgrading. First thing I had to do something about was that polar alignment. It really was a pain, and it was a literal pain. My accuracy was poor doing it that way because I was uncomfortable. And it was very time consuming trying to dial that in. So I ended up getting a polar alignment camera. Now I stand up in a comfortable position when I'm dialing it in. It's very simple, it's very fast, and surprisingly accurate. I was so impressed after getting the first one, I made sure all my telescopes had that accuracy. Remember, I'm putting things out in the driveway. I got to do polar alignment for 3 scopes every night I'm out. I need to have it fast, convenient, and accurate. And this really did that for me. It was a great thing. The other thing I did is, even though I started with a batten-off mask for focus, it's really inconvenient for me because at some point your telescope cools down enough that it's no longer in focus and you have to stop collecting subs to do a manual focus again. So the idea of having a focus motor, and I was using the autofocus of Sequence Generator Pro, I had timed, I had very clear autofocus runs done when the temperature had changed enough to warrant it, or when I wanted to, or when I changed filters in mono. And the quality of my focus really got a lot better. The other thing that worked for me, and maybe this is more important to me than most people because I only have that 3-hour window and have multiple targets that I have to deal with, I got a camera rotator. And the camera rotator goes between the camera and the telescope and allows you to rotate your field of view in very precise ways under computer control. And what I can do is in the afternoon before I'm doing something, I can take Sequence Generator Pro, and it has a framing and mosaic tool, wizard they call it. And you tell it what object you want to deal with. It'll bring up a survey chart showing that object, the photograph. You do a drag, and it'll create a rectangle that shows you the field of view you're going to get with your camera on that telescope. And so you know exactly where you want to center things. But now you can rotate the field so that the stars and the nebulae fit into the frame the way you want. So this is all done, in your armchair in the afternoon. You program that into your sequence. Then later on, things really start to happen more automated. I'm getting ahead of myself here. So when it's time to actually use it, plate solving is used to center the scope on where you're shooting. And then it uses plate solving to make sure the rotation is the precise angle you want. And where that is really handy for me is when I'm shooting more than one target a night, I can change orientations as I go from target to target. That's really handy. If I go another night, I can come back to different targets and get the same positioning I had before. If I have to do flat calibration fields, I can also program that back in and bring it back, and I can do that. So for me, in my 3-hour window, it turned out to be a huge help. The other thing I did is I changed one camera out for a next generation 2600 camera. The new generations of cameras that are coming out now are really impressive. Very low lead noise, very high resolution covering a broader part of the field in your scope. Very deep wells so you can have bright stars that aren't saturating your sensor as quickly. Almost no amp glow, which is something we used to have to calibrate out all the time. Does an incredible job. I only have one of them because the camera's expensive and it needs bigger filters. The filters are expensive. So I'd like to get upgrade all of my cameras to this. I haven't quite figured out how to tell my wife, so don't mention it to her. Okay? The other thing I did is kind of weird. So I had a Teleview 76 that came with a second scope. That's a big finder, right? So I put a big finder on the other scope to match it. I ended up getting a Sharp Star 61 ED PH2. So I have more guide stars, brighter guide stars, and I went even a little bit crazier. I put a focus motor on each one. So now when I'm remote controlling this from inside the house, if I happen to notice that my guide camera isn't in focus, I can do an autofocus series and get it in focus. That's pretty nice. But that's not the crazy part. The crazy part was I really wanted to swap the cameras. I wanted to use the wide field scope to do wide field shots and turn that great big main scope into the most expensive guide scope you've ever seen. That was my intent. I haven't done that yet, but I will. That is what I was shooting for. I also evolved in my software, so I told you about using Stellarium for planning. Polar alignment, I have both PolMaster and iPolar cameras. They both work great. I find the software on the iPolar to be more polished, but more of a pain to use. Or PolMaster, excuse me. An iPolar, it's cruder software, but it seems fast. I mean, I can get polar alignment in literally 2 minutes, and I really like using that. Guiding, I'm still using PhD 2, but I did move to Sequence Generator Pro, and that was such a big step up from APT. That's really neat. Handles all of my automation needs. And finally, I'm using AnyDesk, the free version, so that I can be inside my house and control any of the scopes that I'm dealing with. Being free, and it's very, very responsive. It's very, very helpful when you're trying to work from inside. So setting up 2 telescopes. Well, setting up 1 telescope used to take me up to 2 hours, like I said. I improved and became more efficient at doing that with time. But 2 scopes is still a chore, and I wanted a better way. That better way came from someone that many of you know, a fellow by the name of Rick Albrecht. You know, Rick is a really talented mechanical engineer, knows his way around an observatory and a telescope. And I was trying to get scope dollies to move the scopes, and the supply chain wouldn't allow them to supply them, couldn't do that. So he talked to me about what skills I had for manufacturing. If Rick was doing it, he would turn it on a metal lathe or something, right, and weld it together. I'm not doing that. So I figured I could work with wood. So he came up with a design that would do just that. It would grab onto the scope, lift it, move it out to the driveway, drop it on a few key spots marked on the driveway, and I'm ready to roll. The scope is set up all assembled, all balanced, ready to roll, save a lot of time. This is what he designed and I built. Based on a 2-wheeler, it basically has a frame that supports it and some wheels in the front that'll let you wheel it around and position it carefully. There's a carriage that rides up and down on heavy-duty drawer pulls, and then there's a jack screw with an electric drill which allows you to bring it up and down. Built it, and it's really worked great. So I thought I'd share with you what that looks like. I'll take a few minutes from a video I had up on YouTube. My security camera took this, I didn't realize it. After the fact, I thought, hey, this is cool. This is my little Astro cart. I store everything in it I need. It has a power strip on the back. I run a power cord out to it, and it has a heavy-duty 12-volt supply in the base. So everything is carried out on the cart and connects. All right, so 2 scopes, and I have a way to set it up. 3rd scope? What, are you crazy? So it turns out my oldest son, who was down in Durham, North Carolina, a year and a half ago, presented us with our first grandchild. And when that happened, Janet, my wife, told me that I better plan on spending a lot of trips going down there and spending a long time there because we had more reason to be down there. And I sort of said something like, yeah, but I'm going to miss my exposure time. She said, well, figure it out because we're doing it. And I said, well, I suppose I could make a portable scope. Do what you got to do. We're going down there. I took that as permission. There we go. So I built the rig that was built for portability. Okay. So I finally got a short focal length scope, 400 millimeter. I got a lightweight base. I got a lightweight tripod. But I took a lot of the things that I've done with my other scopes and did it with this scope. So what I bought was an NASCAR FRA 400, which is a quintuplet flat field astronauts. 72 millimeter, 400 millimeter focal length f5.6. This is probably what should have been my first scope, frankly. It would have been a great scope. I reused the 50 millimeter guide scope that I originally bought for this guy, and I got a new CEM 26 mount. This is like a 10-pound mount that's supposed to handle 26-pound payload, and this payload is about 12 pounds. So it's a nice combination, and it's a fairly light combination, and I put a mono camera on it with a 1600. This is the first image I ended up taking with it. So suddenly, in summer, I could see bigger objects that I couldn't photograph before. That was pretty nice. This happened to be a 9-hour exposure, 9.3 hour exposure. Shot it in Narrowband. And this was the first image that really proved to me that I was getting really nice star little dots, and the tracking was good, and everything was working great. This is the first one I took down in North Carolina. Nice wide field view. That one was only an hour in each filter. Not a lot of exposure on that. We had a week down in the Blue Ridge Mountains where we had a place up in the mountains with a great view of the sky, and then we spent another week in North Carolina, and I planned on taking lots of images. It rained every day except the last day. This one was taken on the last day. So that didn't quite work out the way I wanted. Anybody know what that one is? It's the Lion Nebula, and that's 8 hours of Narrowband. So some learnings there. In the case of the portable, we shot off the back of his patio. I couldn't see Polaris at all. I had to do drift alignment. Anybody here ever done drift alignment? Anybody here that's done drift alignment like doing drift alignment?
Compared to polar alignment?
It took me like 45 minutes to do something I was used to doing in 5, so it was a little bit painful. Portable doesn't mean convenient. That's all the gear that had to travel. It was portable, but it wasn't convenient. You're doing this in an apartment complex? Wow, neighbors take note of what you're doing. Lots of noses between curtains looking at what you're doing. Felt a little freaky, but even my family, I'm staying up overnight to do this while we're on a family vacation, and they thought it was pretty weird too. But then I really saw that the scope, as little as it was, could take some great pictures. So now I'm running 3 scopes, okay? So you saw me set up these 2 scopes in my little cart. Now I have this scope, which I don't need a lifter for. I'm the lifter. I pick it up and drop it off. I have a little folding table. I have a laptop driving each of these. If you notice, I have a couple of fans there. That's my anti-mosquito device. So when I'm sitting in front of it. Inside the house, as soon as I get it set up, I go inside the house, and this is what happens on my 32-inch 4K screen. I have 3 desktop sessions watching what's going on with each scope. And then this is an image from a tilt and pan security camera, so I can keep an eye on things. I can even listen. You can tell when the mounts are in trouble or something's going wrong from the sound of it. Processing improvements. You get that data, you got to learn how to process, and that is something you really have to work hard at. I started with Photoshop because that's what I knew, but everyone told me I had to learn Pixinsight, so I started doing that. Steep learning curve. Very powerful. Really hated it. It just seems so different than Photoshop. I really disliked learning it. The paradigms were different, and it was awkward. I really hated it. But you know what? Right now, I can't live without it, so I'm glad I stuck with it. It's very powerful, and I can do magic with it. This is my original data set done with Photoshop, and this is doing a normal processing run with the right calibrations and everything that I got out doing with Pixinsight. So I was able to start elevating my processing game a little bit. So let's look at some more images that have happened more recently. Anybody know what that is? Witch's Broom. That one was a 2-hour exposure, not very long. This one I went a little crazy on. Wizard Nebula. Flexibility of mono. I shot narrowband. I shot RGB at different exposures. I processed everything starless, and then I processed a color RGB star image and folded them in. that was a lot of work. It was a lot of fun. Haven't done it since, but it was a great, fun experiment. So, M33 Revisited. Now I can do composition better. Right? I can box it just the way I want. And this one, it was done 5.5 hours. And it was, this was done with the not a mono camera, but the one-shot color still. But again, my processing was getting better, and framing was getting better, so I was pretty happy with that. This one was an interesting one. I did this one. This is Narrowband. Sorry. This is Narrowband, right? It's the Rosette Nebula. I did a little bit different color rendering than what some people do when they're doing the basic SHO palette. And it also happens to be the first image that I've ever had published. This was published in Astronomy magazine in the January edition this year. So that one I was pretty proud of. This is the very first image that I took with the new generation 2600 camera on the Astro-Physics platform. Of course, it's a sunflower galaxy. I took this in LRGB, but I also took hydrogen alpha and folded that in as well. And when I had this come back, I just danced a little jig. I was so happy to have this level of detail coming out of a 5-inch scope in my driveway. Right? I was just delighted. The camera does some very magic things. So this one, does anybody know, this is a challenge, anybody know what this object is? Take a common name, or I'll take a designation.
ARC 302?
Guesses?
ARC 302?
Nope.
I
look.
hear it.
That's close. Oh, I'm sorry. This is the Twisted Galaxy. This is one of the ARP objects, 214, IGC 3718. This one I did because I figured it wasn't within reach. I said, okay, let's do it anyway, see what I can get from it. And I got a reasonable amount of detail. This is 50 million light years away. It's a weird galaxy with weird features. So I really enjoyed that. Okay, then everyone knows this one, right? Whirlpool Galaxy. This is LRGB, but I added in hydrogen alpha. And you can see in the hydrogen alpha, you can see a little bit of red where all the star forming areas are in the spiral arms. This guy looks a little different, but I've been here before. Right? There's Lagoon Nebula. This time, this is all in narrowband. And what a different look you get from that, right? It's a whole different ballgame than what you normally see. So this is my favorite version of the Eagle Nebula. I shot this last year. This is narrowband once again, but I was just delighted with the amount of detail I was able to pull out of that. All right, this is the Tulip Nebula. This is 12.8 hours of exposure. This is an area so rich in stars, it's almost hard to process. There's a star everywhere. It makes it harder to process it. I sent this out, and I got an interesting comment back from someone. So I have a challenge question for you. Okay. What historically significant, famous object was discovered and confirmed in this field of view? Any guesses? Right. I'll mention that I got a note back saying, "Wow, you captured the bow wave. Great job." I said, "Thanks." What bow wave? What's he talking about?
Cygnus X1.
Cygnus X1. That's right. This is. If you look at this, there's a very faint bow wave right here, and this guy right here is a visual companion to X1, the first confirmed black hole. Now, because you got that right, I know most of you have been staring at this hat and saying, "I wish I had a hat like this." I mean, the presentation's great, but the hat is what I'm really looking at here. You earned a Cosmos Cosmo hat.
What do you call it?
Here's that zoomed in a little bit. I didn't even know I captured it, but you know, that's what's really cool about this, because sometimes I capture the main object and I'm looking through the processing. What's that? What's that? And then I gotta do digging. I feel like I'm an explorer doing that, and I have a lot of fun doing that. Now this one's kind of an interesting one. This is the second image that I had published. This was in the May edition of Astronomy this year. This is a narrowband image of the Dumbbell Nebula. It doesn't look like the Dumbbell Nebula I ever saw through a telescope. And there's kind of a reason for that. Let me show you what happens. This is the mono camera, and I've got 3 images: hydrogen alpha, oxygen 3, and sodium 2. They're different objects. On the far one over there, that looks like the dumbbell I see in the telescope, right? What's this oxygen 3 guy? Look at these soft angel wings that are coming out from it, right? Then look at this guy, hydrogen alpha. This looks like this lacy ring filled with detail. Now I gotta munge those together and see what it looks like. This is crazy. I made all different kinds of renderings on it before I ended up with what I did. But this is what's fascinating when you can do narrowband. You're only looking at these slices that are 7 nanometers wide, right? And they're just such a different view of the same object you can get from it. And it's throwing away all that other light, so it gives you detail that you can't get from a broadband. Now this one, I published as a failed image. The reason I call this a failed image is I had horrible haloing and reflections around Elmatec here. Just terrible. And I did every trick in the book to make them go away. And I sort of muted them, but I didn't make them go away. So I put on my website my good images and my failed images. I put this out there as a failed image. And to my surprise, I had tons of people coming back saying it was one of their favorites. Okay, I don't get it. To me, it's a failure, but a lot of people seem to enjoy it. Okay, this one I was really happy with. Suddenly, I have a wide frame scope. I can get the entirety of M31 in there, and I can get hydrogen alpha in there as well. So this was a 6-hour exposure, LRGB with hydrogen alpha, and I was really pleased with. This is one of my favorite ones. So I have another challenge question. I'm going to save that for another one. Hang on. Hold that thought. Anybody know what this is?
What was that?
The little Rosette. Little Rosette. I've never heard of this. I've never heard of this object before. So I went and found it, and I was amazed in narrowband what a rich and bright and detailed object it was. I'd never heard of it.
This is when we have a Schmidt camera later.
Oh, that would be amazing. This is also one that got me into Sky and Telescope this year. It was in the June edition. So that was pretty good. Well, someone's earned another hat.
Yeah.
No, I cheated. I'm not reading.
I'm giving them away one way or another, and you're going to take them.
That's my attitude with brisket.
You deserve it for this.
So this is almost 12 hours of data narrowband on the heart. And I love the blues you can pull off. That's something that I really enjoy working with.
Helix.
This is the helix. Yep, beautiful. I was trying to go for, you see images where you see these striations in the core there, and I was just beginning to pick them up, but it was a real challenge for me, because you remember my picture of the south driveway and how it got really narrow at the bottom? That's where this guy was. So I was getting like an hour a night, and I'm looking through so much atmosphere, and then it's muddy and murky, and the data wasn't great. But I kept collecting data, and this is what I was able to pull up. I saw this as a failure. And again, other people were saying, no, that's pretty good, I like that. All right, now this is a weird one. This is the California Nebula. Did you ever see the California Nebula looking quite like that? That's because it's a big object, and people use wide field scopes on it. Well, I had all objects picked out from the scopes that I had, and I had a 920 millimeter scope that had no target for 3 hours. And this is the only thing in the neighborhood, and I said, point it at the middle, capture some narrowband data, let's see what we can do with it. And what I ended up doing is I picked up 10 hours of data with it. When you get that much time in there, a lot of detail and structure in that. So it doesn't look like the California Nebula, but I was kind of fascinated by the level of detail that I was able to pull out there. This, of course, is the Seagull Nebula. This is interesting because I had plans to shoot this for 4 nights, and I got 1 night, and it got clouded out. So this only has 2 hours of data. 2 hours for a narrowband image is nothing. I was kind of shocked how much color and detail I was able to pull out of it, even with that short integration time. So that was a surprise for such a low exposure time. This, of course, is the Pinwheel Galaxy. This one is 11.3 hours. This was really important for me to get because if you look at my website, there are 2 other pictures of this object, and they are atrocious. They are embarrassingly bad. I had to overcome this object. Two attempts, and they were horrible. This one I really worked at, and I did put hydrogen alpha data in there too, so you have a little bit of the knots and forming stars in there. It's not the best image I've ever seen of this one, but made me feel good after having really bad versions of that in my portfolio. So this one is one of my favorite galaxies. I remember discovering this on Rick Ulbricht's 16-inch telescope 30 years ago when I was standing on the 4th arm looking through the eyepiece, scanning through a field of stars, looking for something interesting to see. My weight was not deflecting his scope. He built pretty heavy duty. And suddenly this splinter of light came across the field. And we put it under power and we could see the dust lane. We didn't know what it was. So we finally figured it out. But ever since then, it's been one of my favorite galaxies. I shot this recently, and I've been working on techniques to get as much sharpness out of my 5-inch scopes as I can. And in doing that, I thought it really paid off. I mean, I'm zoomed in. That's the same image. I just zoomed in a little bit. And the level of detail that I'm getting in the dust cloud there is amazing. The other thing is look at the color gradient. The little color gradient as you get out into the arms there. I was very pleased with that. Then we got this little fuzzball in there. And I thought it was a defect in my data. Turns out that little fuzzball is IC 3571. It's an irregular galaxy, which is very blue. So it's again, I'm looking at this and I'm saying, oh man, what got on there? I'm going to have to take that out. And then I found out it's a real thing. Don't take it out. Leave it alone. That's pretty cool that you got it. Thor's helmet. This is another one that was only 2 hours. I took it at the same time as the other one that was only 2 hours. And I didn't think too much of it. It was kind of short, but in the August edition of Sky at Night, the digital edition that's going to be published. So they just gave me a notice on that recently. So this is kind of an interesting one. This is M33. I've shot it several times. I've been working on more sharpness, more detail, and I decided to give it a go. This is 8.5 hours LRGB data, and I was really pleased with the resolution I was able to pull out. In fact, if you're used to taking pictures of M13, or even if you do wide field viewing of it, you usually see this little galaxy, this little fuzzball popping up in there. That's a pretty standard thing to see. But if you look really careful, there's a tiny, tiny little galaxy in here too. So challenge, anybody know what either galaxy is?
6702 or something like that. And
6203 months ahead.
Close, very close, but not quite. So let's look at them. So the first one was 6207, 6207. I zoomed in on it, and I've taken this before, it's just a fuzzball, right? But I'm looking at it, and I can see evidence of a spiral structure. I can see the warm glow at the core. I can see the coolness of the outer. There's even hints of extended. The detail I was getting there, I was really impressed with. Then I looked at that other little smudge. I mean, I barely see it on that plate. And I'm looking at it, and I can see the core. I can see a hint of spiral structure in the arms, and I can see another little edge on spiral even behind that. It's like, wow! It's like, so it's easy to get very excited when you're working with this data. You never know what you're going to end up finding. So this is one I shot very recently, Blue Horsehead Nebula. How many people have heard of the Blue Horsehead Nebula before? There's a couple. I had not heard of it before.
It was a great astronomy picture today of that.
It's a beautiful object. I mean, it's another one of those that's very south, and so I have a hard time shooting it because of the trees, and I can't get much light from it. But I stepped at this for several nights, and I thought with the star in there forming the eye for the horse's head, it was really aesthetically quite pleasing. So sometimes astrophotographers like to look at how they've evolved. So some of the images you just saw, I'm going to show you again very quickly, and it gives you a feel for how I've evolved. Let's start with the Eagle Nebula. That's my first one. That was 2019. I loved it. You can see it, right? I was very excited. This is one I took a year later, and this is the one I just recently took. So pretty happy with that progression. M13, there's my very first attempt on M13. This is 2019. Next year, I got something a little bit better, more stars, sharper, and some color in there for once. But the one I just showed you is where I'm really happy. Then the Andromeda Galaxy shows you that first one. That was my first big wow. I got fancy when I had the camera rotator. I was giving it a composition. I can't fit it all in, but I can show the companion galaxies in there. So I was able to get that in. By the way, which galaxy is this?
No.
Then this one has to be
That's 32.
32.
Now, the challenge question is, what's the blue thing over on the left?
What's that?
What's the blue thing on the left?
The blue thing?
Yeah, there's an NGC in the disk.
Oh, yeah, in here.
Yes, 625.
Yeah, I don't have.
That's 603. See, give the man another hat.
And there's my final one. And the fact that I can fit it all in is what made me happy. Right now, I've been getting a very good following with being able to document all of the projects that I do. And I'm doing unique things in there that I share every processing step, and I'm getting a lot of positive feedback for that. So this is a great thing for me because I can share my projects and tell the story the way I want to tell the story. And when we have cloudy days, which never happens around here, I've got some fun things I can work on. So here I am today. I got 3 telescope platforms, 106 imaging projects completed, 468.7 hours of integration, a lot of lost sleep, a website to keep me busy during the cloudy times, and I'm planning an observatory for someday in the future. And from a journey for astrophotography, I'm having a blast. Remember I talked about this particular sequence? This is the journey. These are the steps in the journey. Going through the phases is the journey, really. That learning process, that's what this is really all about. Different people go through these phases at their own rate, and that's okay. Some of the phases overlap. Some of the phases never end, and that's okay. Key in this is you don't get frustrated. You make mistakes, and you learn from them, and you keep going. And don't be afraid to ask for help. There's always people who have the same problem and can help you out. Above all, it's the journey. Enjoy it. All the good and the bad and everything else. And with that, I'll end, and thank you for your attention.
Keep supporting this guy.
How do you like to larger scopes? How do you compare the astrophysics and the Lion Nebula?
I would say that the astrophysics has a superior contrast, and it has a little bit longer reach. So it's got like 1080 focal length versus the 920 the astrophysics over the Williams optics. They're very close. The Williams optics is a beautiful scope. The astrophysics is a beautiful scope. I felt like I hit the jackpot with both, really. I tend to use the longer focal length for my Galaxy shots because it has the better camera on it, and it gives me a little bit better image scale. But, they're both great. else?
How do you manage observing from inside of the house? Do you have like long cables or a local laptop?
Well, it's Wi-Fi, right? So I bought 3 identical reconditioned laptops. They each are connected to each telescope, and they run the software that's controlling the sequence. I also have AnyDesk software, that's the name of the software, installed on it and on my computers inside. That lets me to do remote screen share. Once I have set things up physically, and I've dialed in the polar alignment, I can now connect from inside the house, and it's just like working on the keyboard outside, except I don't have cold air or mosquitoes bothering me. And I have to go back out if something goes wrong, or when it's the end of the night, or when I want to do flat exposures, I got to put the light source on the tube and shoot that. But it keeps me sort of out of the cold and away from the mosquitoes. That worked out pretty well.
How do you deal with meridian flips and all the cables and everything? Is there tangling? Is it risky or?
Well, someone was mentioning in my pictures that I do a really good job on cable management on the scopes, and I've even written articles on how I go about doing that. The reason I do that is because I used to get snagged up in the rat's nest of cables, and during a meridian flip, that's the worst time you deal with. Once I got the cabling down, meridian flips just happened, and it wasn't very hard to get them going, and that just is transparent. I don't even pay attention to it. It's completely automated. The only thing that happens on the flip is oftentimes it messes itself up and it's not really pointing where it thought it was. But as part of this restarting the sequence, it does a plate solve and it realigns the mount and it recenters and re-rotates so you have exactly where you were before. And that's oblivious to me. Hopefully I'm sleeping while that's happening.
It's all automatic?
It's all automatic. It's the only way to fly. Anything else?
When you shoot your flats, you do it through each filter? Or you just do luminance?
I do it through each filter, and I tend to do it every night. The problem I have is I move the scope physically. If there's dust sitting on a filter and I jostle it, it can shift position. So I tend to do flats every night for every object. And then when I do my stacking, I make sure that the appropriate lights are calibrated with the appropriate night flats. And I do it for every filter. You pretty much have to. Flats are really a powerful tool for calibrating defects out of the system. You know, optical defects. Pardon me?
Using the weight t-shirt method?
I never tried that. It sounded crazy to me. Instead, I went on Amazon and I bought a $19 tracing panel, LED tracing panel, and I sandwiched it in 2-inch closed foam with a hole cut out the size of the scope. And I figured out what brightness level gave me the best exposure, put it up there, calibrated the exposure, and then that's what I do now. I have a big one for the 2 main scopes, and I got an itty-bitty one for the smaller scope. And that's really convenient. Works out nice. It cost me $20. No t-shirt, don't have to worry about the bright sun, and it does a great job. Yes?
What are your 3 favorite images of everything you've had?
That's a tough one. I'm really partial to that M31, just because I just think it's such a beautiful galaxy. I'm really happy with that. My M16 in Narrowband, I just had a huge metal print made of that I had no place to put in my house, but it didn't matter. I wanted to have a metal print. So that's probably another one that I'm super happy with. And then probably the Sunflower Galaxy. The first one I did with a new camera, and I had such wonderful detail coming out of it. It was one of those things where it's like you're opening a present for Christmas. You don't really know what's in the box until you're done with the processing, and then you're done with the processing, you look at it and go, wow, it's better than I would have guessed. And so I was delighted by that. Yes?
So when are you building the observatory?
Well, I'm actively working. I have a plan. I even have I have an example observatory that I'm going to mimic. It's a roll-off, 15 by 17 with 4 piers. It can be fully automated. My big problem is I have to buy new land. I'm not building an observatory where I see such a tiny slice of the sky. And my wife won't let me buy an Astro chainsaw to clear the land. So we're actively looking for land to build a house or an existing house that has, good good location for building an observatory. So buying the land is the thing that's slowing us down. It's a really crazy market out there right now. We were looking 8 months, and we've only put in one offer so far, and we lost out on that, so the search continues. Okay, well, thank you all very much. It's been a great
Thanks, Pat.